If you are new to the channel, then subscribe the channel and press the bell icon for further notification.
Okay student, welcome you all to this new lecture in basic level where you are solving previous year Tripura University questions on method of differentiation. So in this lecture we will be solving question number 20, 21, 22, 23, 24 and then 25. Okay, then let's try to solve these questions. If y is equal to this, then prove this. Y is equal to a cos log x plus b sin log x. Proof I am writing here, x square y2 minus xy plus xy1 plus y is equal to 0. So what we will do, we will differentiate first with respect to x. So it is a, first differentiation of cos is sine, then you have to go inside, log is 1 by x plus b, again differentiation of it is minus, cos is minus sine, sine is cos, then you have to go again inside, log x is 1 by x. Now you can see with y there is a x, so you keep this x, take LCM and send this x that side, dy dx. So it will be minus a sine log x plus b cos log x. Now you differentiate. So if you take x constant, it is d square y by dx square, plus if you do dy dx, then x differentiation of x is 1. And now again differentiation of sine is cos, again log x will be 1 by x, plus differentiation of cos is minus sine, again log x is 1 by x. So again you send this x this side, so it will be x square d square y by dx square plus x dy dx, and if you take minus common, it will be a cos log x plus b sin log x. And what is this? This is the original function. You can see a cos log x, b sin log x, so it is minus ay. So you can bring this y this side also. This one you can write y2 and plus, sorry, it is only y is equal to 0, so it is proved. Now if you come to question number 21, find dy dx of y is equal to this. So y is equal to log sec x plus tan x. So what will be dy dx? First you do differentiation of log, that is 1 by x. Then you do differentiation of inside this one, chain rule. So sec x is sec x into tan x and tan x is sec square x. If you take sec x common, it will be sec x plus tan x, because sec x will be there, tan x will be there, and denominator also sec x plus tan x. So answer is sec x. Now in 22, if y is equal to this, then prove that y2 minus m square y. Okay, what is given? Y is equal to a e to the power mx plus b e to the power minus mx, and you have to prove y2 minus m square y is equal to 0. So what you have to do, again you will differentiate it, dy dx is equal to a e to the power x is e to the power x, again you have to differentiate mx, so m will come, and b e to the power minus mx, again you have to differentiate this one, so minus m will come. So here nothing is there with y2, so you can directly differentiate now one more time. So d square y by dx square, if you do, it will be a m e to the power mx, again one m will come, because this is already there, so e to the power mx is e to the power mx, again this mx you have, if you differentiate again, that will be again an m, so it will be minus bm e to the power minus amx minus again 1m will come, because e differentiation is this one, minus mx is minus m. So finally what you will get, your y2 is equal to m square, if you take common, then it is a e to the power mx plus b e to the power minus mx, so which is your original function, this one. This is your original function, that is they have given, this is its y, so you can write it y. So it is y2 minus m square y is equal to 0, so proved. In 23, if y is equal to this, then show that this. So again the proof type, y is equal to x square minus 1 to the power n, and you have to show x square minus 1 y2 minus 2 1 minus, sorry, plus 1 minus x xy1 minus 2 xy is equal to 0. So again before going second derivative we have to check. So first derivation is easy, so dy dx, if you do, it is n x square minus 1 to the power n minus 1, then again for x square you have to do 2x. Now you have to see here, 1 x square minus 1 is already with there, so you need this one. So for because you need this one, it is 2nx, I will keep it as it is, so I will put x square minus 1 to the power n divided by x square minus 1. So this n I have directly written, and this minus 1 I have put in with 1. So you can write it easy. If you divide, so one power will be reduced. So this one I will bring with this one, x square minus 1 dy dx is equal to, because I have seen, because in the proof it is already there, so you have to bring that side before going for second derivative, otherwise it will not come. So now again you differentiate with respect to x, so it will be d square y dx square plus, if you do dy dx, x square is 2x, and now you can write it, before going this one you can write it y also, x square minus 1 to the power n is y, so it will be easy. So now if you differentiate, it will be 2nx dy dx plus 2ny differentiation of x is 1. So now if you bring everything this side, it will be y2 minus or plus, you can take common dy dx. So if you take dy dx, that is y1. So here it will be 2x minus 2nx and minus 2ny is equal to 0. You can take n common, 2 common, so it will be 1 minus x into n y1 minus 2 ny is equal to 0. That is proved. Now if you come to question number 24, find dy dx. Again it is of parametric format. So y is equal to 2 sin theta minus sin 2 theta and x is equal to 2 cos theta minus cos 2 theta. They have asked you to find dy dx. What you will do, dy d theta divided by dx d theta, parametric form, because there is no direct relation y and x, there is a via relation, so you have to differentiate with respect to theta, then divide. So it will be 2 cos theta minus cos 2 theta, again 2 will come, so it will be 2 cos theta minus 2 cos 2 theta, dx d theta minus 2 sin theta, cos theta differentiation is sin, so minus sin 2 theta, again 2 will become, because you will do differentiating theta, so 1 2 will come, so it is minus, so you can write 2 sin 2 theta, so therefore dy dx will be equal to dy d theta. If you take 2 common, it will be cos theta minus cos 2 theta divided by this sin 2 theta minus sin theta. So that is your answer. Now if you come to question number 25, if y is equal to root x plus 1 by root x, you have to prove 2x dy dx plus y is equal to 2 root x, because it is of single derivative. You differentiate, put it on left hand side, you will get right hand side, no issue. So dy dx is equal to root, what is the differentiation of root? 1 by 2 root x plus, it is of x to the power minus half, so it will be minus half x to the power minus half minus 1, n x to the power n minus 1, so it is 1 by 2 root x and it will be minus 1 by 2 and x to the power minus 3 by 2, so that means x root x. So your LHS will be equal to, if you put everything is LHS, 2x dy dx plus y, so 2x instead of dy dx it will be 1 by 2 root x minus 1 by 2 x root x plus y is equal to root x plus 1 by root x. So if you take common, so 2 get cancelled, x into root x will be root x, 2x get cancelled, 1 by root x. So this cancel, you get 2 root x, that is proved.
If you like the video, then press the like button and please give your valuable comments in the comment section.